Welcome to Python Fundamentals. In this module, we'll explore the foundational elements of Python programming that form the building blocks of every Python script. Understanding Python's basic syntax is essential for writing concise, practical code. By mastering the basics of Python, you'll establish a solid foundation to serve you well as you progress through your Python programming journey. This lesson on Python fundamentals will cover several key concepts essential for beginner programmers. First, it explores comments, explaining how to document code effectively. Next, it dives into variables and constants, teaching how to store and manage data. The lesson then reviews data types such as numbers, strings, and booleans, followed by basic operations like arithmetic and comparison. You'll also learn about string manipulation and formatting, critical for handling text data, as well as working with lists and dictionaries for managing collections of data. Lastly, the lesson covers file handling, providing an overview of reading from and writing to files in Python. These topics form the core foundation needed to write and understand Python code efficiently. In Python, a comment provides additional information about the code. Comments are essential for code documentation and are ignored by the Python interpreter, meaning they do not affect the program's execution. The primary uses of comments in Python are 1. Documentation. They help explain the purpose and functionality of the code, making it easier for others or the programmers themselves later to understand the logic and reasoning behind certain sections of the code. 2. Code readability. Comments improve the readability of the code by breaking it down into understandable parts, especially for complex algorithms or functions. 3. Debugging. They allow programmers to temporarily disable certain parts of the code by converting them into comments, providing a sense of security in isolating and fixing issues without deleting the code. 4. Collaboration. In collaborative projects, comments help different team members understand each other's contributions and maintain consistency in coding practices. In Python, single-line comments start with the hash symbol. Single-line comments in Python are used to annotate code with brief explanations or notes, enhancing readability and maintainability. They begin with the hash symbol, allowing programmers to include comments that the interpreter ignores during execution. These comments can be placed on their own line or at the end of a code line, making them versatile for clarifying complex logic or reminding developers about specific functionalities. Utilizing single-line comments effectively helps in documenting code, making it easier for others and oneself to understand the purpose and functionality of different sections in the future. Multi-line comments in Python help provide detailed explanations or annotations that span multiple lines, enhancing code clarity. While Python doesn't have a dedicated syntax for multi-line comments, they can be created using triple quotes. These comments can be placed anywhere in the code and are ignored by the interpreter, making them ideal for describing complex algorithms, providing usage instructions, or outlining project goals. Employing multi-line comments effectively helps maintain organized and understandable code, especially in larger projects where context and clarity are crucial for collaboration and future development. Variables are used to store and manipulate data, and their values can change during the execution of a program. Here's an explanation of what you need to know about variables. A variable is a named storage location in the computer's memory where data can be stored and manipulated during the execution of a program. In Python, you can create a variable simply by assigning a value to a name using the assignment operator equals. Python is dynamically typed, meaning you don't need to explicitly declare the variable type. The type of the variable is inferred from the value assigned to it. Variables can hold various data types, including numbers, strings, lists, dictionaries, objects, etc. An assignment statement creates a variable. It begins with the variable's name, followed by the assignment operator, equal sign, and the value assigned to it. In this example, the equal sign is used as a basic assignment operator to tell the program interpreter that the variable name x has a value equal to that of the numeral 10. Storing information using variables in Python allows programmers to assign and manage data efficiently within their programs. Variables act as containers for data, enabling easy retrieval and manipulation throughout the code. When a value is assigned to a variable, it can be referenced by its name, which simplifies operations like calculations, data processing, and user interaction. Python's dynamic typing allows variables to hold different data types, such as integers, strings, or lists, without the need for explicit type declarations. This flexibility facilitates rapid development and experimentation, making variables fundamental for organizing and utilizing data effectively in any Python application. Naming variables in Python is crucial for writing clear, maintainable code. Variable names should be descriptive, reflecting the data they hold, which enhances readability and helps others or oneself understand the code's purpose. Python follows specific naming conventions. Variable names must start with a letter or underscore, can contain letters, numbers, and underscores, and are case-sensitive. Avoiding reserved keywords and using lowercase letters with underscores for multi-word names, for example, user age, are recommended. Consistent naming conventions promote better collaboration and code quality, making debugging and extending functionality in the long run easier. Variable names in Python must follow specific rules. They can contain letters, numbers, and underscores. Variable names are case-sensitive. Constants in Python are identifiers of variable names that hold values that should not be changed during the execution of a program. They represent fixed values, such as numbers and strings whose values remain unchanged throughout the program's execution. Here's an explanation of what you need to know about literal constants. Constants are identifiers of variable names used to represent fixed values in a program. They are conventionally named using uppercase letters to signify their immutability. Constants hold values that are not meant to be changed during the program's execution. While Python does not enforce constant immutability, the naming convention helps convey the intent that the value should remain constant. Common use cases for constants include mathematical constants, for example pi, configuration settings, and predefined values. Constants improve code readability and maintainability, and help avoid hard-coding values that may change. They represent values that remain unchanged throughout the program's execution. Python does not have built-in support for true constants, but the naming convention helps treat variables as constants. Constants are typically not intended to be reassigned or modified after their initial assignment. Python data types define a variable's values, playing a pivotal role in how data is stored and processed. Common data types include integers for whole numbers, floats for decimals, strings for text, and booleans for true-false values. Python also offers complex types like lists, tuples, dictionaries, and sets for handling data collections. Each data type comes with specific behaviors and operations, making it essential to choose the appropriate type for your task. Understanding data types is fundamental to effective coding, ensuring proper handling, manipulation, and storage of information in Python programs. Python operators are special symbols used to perform operations on variables and values. They allow for various types of operations, such as arithmetic, for example, addition and subtraction. Operators help in manipulating data, evaluating conditions, and controlling the flow of a program, making them fundamental tools in Python programming. In Python, operators are symbols that perform operations on variables and values. There are several types of operators. Arithmetic operators perform basic mathematical operations. Comparison operators compare values, logical operators evaluate logical expressions, assignment operators assign or update values, and membership operators check for membership within sequences like lists or strings. Each operator type serves a specific function, helping manage data efficiently in Python code. Arithmetic operators in Python are used to perform basic mathematical operations on numbers. These include addition, subtraction, multiplication, and division. Other important operators are modulus, percent, which returns the remainder of a division, exponentiation, for raising a number to a power, and floor division, //, which returns the largest integer less than or equal to the division result. Arithmetic operators are fundamental for calculations and are commonly used in various programming tasks. Python strings are sequences of characters used to represent textual data encapsulated within single, double, or triple quotes. They support various operations, including concatenation, slicing, and formatting, making them versatile for handling text. Python provides a rich set of built-in methods for string manipulation, allowing users to modify and query strings efficiently. Additionally, Python's support for string interpolation through fstrings or the format method enhances readability and simplifies the incorporation of variables into strings. Strings are fundamental in Python and crucial in data processing and user interaction. Triple quotes in Python are designed to create multi-line strings, allowing text to span multiple lines without requiring explicit line breaks. This feature is particularly useful for writing long text blocks, such as documentation, or embedding formatted strings that maintain their layout. Triple quotes also serve as a convenient way to create multi-line comments, as the interpreter will ignore any text enclosed within them. Additionally, triple-quoted strings can include single and double quotes without escaping, enhancing flexibility in string creation. Overall, triple quotes simplify string management, making code cleaner and more readable. Python lists are versatile ordered collections that can store a variety of data types, including integers, strings, and even other lists. Defined using square brackets, lists allow for easy manipulation and dynamic resizing, making them ideal for managing collections of items. They support various built-in methods for operations like appending, inserting, removing, and sorting elements. Lists are zero-indexed, meaning the first element is accessed with index 0, facilitating straightforward element retrieval. With their flexibility and functionality, Python lists are essential for tasks involving data organization, iteration, and complex data structures, making them a foundational aspect of Python programming. Python dictionaries are powerful unordered collections that store data in key-value pairs, efficiently organizing and retrieving information. Dictionaries are defined using curly brackets. Dictionaries allow for rapid access to values based on their unique keys, which can be of various data types, including strings and numbers. They support numerous methods for adding, removing, and modifying entries, making it easy to manipulate data. With their flexibility and efficient lookup capabilities, Python dictionaries are widely used for tasks that require structured data representation, such as configuration settings, data storage, and representing complex relationships. Sets in Python are ideal for handling unique collections of items, performing set operations, and efficiently checking membership. They offer a range of methods and operations for manipulating and querying sets, making them a powerful tool for many programming tasks. Sets are used to store multiple items in a single variable. They are one of 4 built-in data types in Python used to store data. The other 3 are lists, tuples, and dictionary, all with different qualities and usage. A set is an unordered, unchangeable, and unindexed collection. Sets are written using curly brackets. Unordered means that the items in a set do not have a defined order. Set items can appear in a different order every time you use them, and cannot be referred to by index or key. Python files are a key component of data management, allowing users to read from and write to files easily. Using built-in functions, Python enables the handling of various file formats, such as text and binary files. The process typically involves opening a file, performing operations like reading or writing, and then closing the file to ensure data integrity. Python's context managers simplify this workflow, automatically managing file closing, which enhances code safety and readability. Understanding file handling is essential for tasks like data persistence, logging, and configuration management, making it a foundational skill for any Python programmer. In this lesson, we covered the core fundamentals of Python, including variables, data types, operators, control structures, and functions. With these essential building blocks, you're now ready to move forward in this course and get a much more in-depth understanding of the components that make up Python programming. By the end of the course, you will be able to start writing more complex Python programs and begin to explore more profound concepts. Keep practicing to solidify your understanding, and you'll continue to improve your coding skills as you tackle new challenges. Thank you for watching.